What is mean centering? In this video, we will look at what mean centering is, why we use it, how to use linear algebra to perform it, how Python is used for mean centering, and the benefits of using linear algebra in mean centering. If you need a refresher or are new to concepts we will be talking about, I recommend to watch the listed videos about matrices and their operations. Why do we perform mean centering in machine learning? Mean centering helps put distributions on equal footing, so comparisons are clearer. Mean centering is a key step in feature scaling that allows us to standardize data so large-scale features don't dominate the model. To standardize the data, we subtract the population mean from the sample mean and divide by the population standard deviation. Neural networks train better when we standardize the inputs symmetrically around zero. Note that centering doesn't alter correlations or predictionability or the distances between points if they are scaled. It only changes the coordinate system for easier optimization. Now let's do some mean centering. To get a feel for how mean centering works, let's do it manually. We have a 3x2 matrix here. We can also say this matrix has 3 samples and 2 features. We start by finding the average for each column, and we get 4 for the left and 6 for the right values. Now let's subtract the means we have calculated with each value in the corresponding columns. And we get our centered matrix. Next, we will perform this using matrix algebra. Let's do this again with matrix X. First, we construct a 3x1 column matrix of all ones, denoted by 1 subscript 3 as shown here. Next, we multiply a transpose of the all ones matrix, which is a 1x3 matrix, with X. Finally, we divide by the number of rows in our original matrix 3. The original matrix is 3x2, while the result is 1x2, so they can't be directly added or subtracted. With the matrix we just calculated, we can multiply it with the 3x1 all ones matrix to get the mean matrix shown as M. Finally, we subtract the mean matrix from the original matrix to center the data. This method has a lot more manual steps than what we did in the previous slide, so why did we do it this way? We will come back to this question in the next few slides. We can also compute mean centering as a Python program. We would use NumPy, a powerful Python library used for numerical computing. The NumPy library has a function to create an array filled with ones, and the shape at index 0 returns the number of samples, rows, in matrix A. Next, we find the dot product between the transpose of I3 and the matrix A and divide it by the number of rows in our sample. Finally, we subtract that mean matrix from the original matrix to mean center. Alternatively, you may run this as a Python program. So why did we do all of those steps with matrices and their transposes when we could use simple arithmetic to find 2 means? The reason is that when we deal with larger data sets, simple calculations become impractical and slow. Matrix operations, on the other hand, handle large amounts of data more efficiently. Additionally, modern GPUs in our computers make computations even faster. Mean centering requires transforming operations, summation, and scalar operations when we find the average for each column, and subtraction. Performing each step one after another is inefficient for computers. Thankfully, modern GPUs allow for parallelization of matrix operations. There are two caveats, though. Some operations must wait for others to finish. For example, when finding a result matrix's entry, the products in that spot need to compute it first before they can be summed. Also, GPUs do more than parallelize computations. They use pipelining, scheduling, and other optimizations for efficient computation. Before we wrap things up, let's do a brain teaser. How many operations can be run in parallel when mean centering the example matrix X? Remember, not all operations can be run in parallel, and some operations need to wait until their dependent operations are completed. Also, what is the optimal number of GPUs needed to complete the mean centering operation? Hint, the optimal number is the minimum number of GPUs needed to complete all operations in parallel. Using more than what is minimally required is not the optimal solution. To recap what we just learned, we now know what mean centering is, how to perform it, and how we can use it for machine learning. Now, I recommend you to look at the listed videos to learn about matrix operations and matrix-related concepts that will pop up in the future.